Welcome back to the Open Polkadot Bootcamp made by the OpenGuild community. And today we're gonna discover the architecture of substrate and also how you can use substrate to create a new blockchain. Today video is gonna have a few different subsections. The first one gonna be like go to the overall architectures of substrate and a blockchain network. Then later on, like we're gonna learn about like substrate architecture of substrate, like the node, the runtime, and also like walk through the code of the substrate node a bit. Then like later, I'm gonna like use a tool called like PopCUI to create a new blockchain so that you can also like use that on your local and create your own blockchain and run on local. When we want to create a new blockchain, we have to understand what is a blockchain first. So here is a basic architecture of blockchain network. So a blockchain network, especially advanced supercomputer blockchain network like Ethereum or Polkadot or Solana, they have like different architecture compared to like primitive blockchain network like Bitcoin. In the case of Polkadot parachain or Polkadot blockchain, we have like three different core components of the blockchain. The first one gonna be the database layer, or it's also a distributed ledger. Here is we have like a structure of linked list of block. Like these blocks are the atomic structure of the whole blockchain network that store the record of data at that timestamp. And when like the next block added to this block, it's used like the previous hash of the hash of the previous block. So in that case, like the whole network are cryptographically secure. The upper layer of the database layer is the P2P network. This P2P network has multiple nodes that is participate into the network and connect with each other. These nodes are simply your computer or maybe like your mobile phone, and it's handshaking and connect with each other to form the P2P network. Runtimes that like contains like all the core programming logic of the blockchain, such as like access management and NFTs or governance. So what is a Polkadot SDK? I think like in the previous video, you already learned a bit about like Polkadot SDK and also the substrate. But here we also like have, we're gonna like quick go to some key features of the Polkadot SDK. So the Polkadot SDK provide your blockchain an ability to like forkless and seamless upgrade. Different from like other blockchain like Ethereum, whenever you want to do an upgrade, you have to do a hard fork. In the case of the blockchain built on Polkadot, whenever you want to do an upgrade, it doesn't require a fork. Highly customizable runtime. So substrate like provide you like a full set of like different library and features that you just add to your blockchain, and it's gonna become a well-functional blockchain with all the functionalities provided from the ecosystem. What is Substrate Framework? A blockchain builder tool that allows you to build a blockchain on top of the Polkadot protocol. Polkadot itself is not a blockchain, but it's a layer 0 protocol, sit like underlying of the whole ecosystem. And then like every blockchain just built on top of it and connect to the whole interoperability hook called like a relay chain. Then we have like create a new blockchain with PopCUI, running a solo chain and running a local relay chain per chain network. The difference between a solo chain and a relay chain per chain network is that a solo chain is simply a blockchain that stands alone and this doesn't have to follow the rule of the Polkadot network. However, like if they want to use the key features of the Polkadot network like native state security or execution sharding, they have to connect to the Polkadot network as a parachain, connect to a relay chain, and then yeah, they're gonna like receive all the key features of the Polkadot. So before we move to the architecture breakdown of the substrate node, we're gonna want to clone the code base first. Here like I use like one repository that I already forked from Parity called like Polkadot SDK minimal template. And on my local, I already clone. You're gonna do like git clone the Polkadot SDK minimal template. And here I already clone a Polkadot SDK minimal template to my local, so I don't need to clone it again, but you have to run that command. If you're not familiar with Git, just search on Google like how to install Git, and you're gonna there's gonna be like a bunch of tutorials guide you to that. So here's like the code base of the Polkadot SDK minimal template, and in this code base of the Polkadot SDK minimal template, you're gonna find like there's a node, a palette, and the runtimes. And you may like wonder like what's the difference between the runtime and the node. I think that we already go through it in the beginning of the video, right? So here, like the runtime gonna define all the core programming logic of the blockchain network. That is like the first way, create a new blockchain with like Polkadot SDK. There's another way that using a tool called PopCUI. PopCUI is a tool developed by a team in the Polkadot ecosystem called Rogue. PopCUI is provided an all-in-one tool for Polkadot development. So to install the PopCUI, you're gonna run this command like cargo install force lock PopCUI. Or you can also like clone it directly, you install it directly from GitHub. So because I already like install it on my local, so when you install it running that command, when you select PopC version, you're gonna find the PopCUI version like 0.40. This is my like, current version of the PopCUI. So when you run like the pop help, it's gonna like provide you some set of command that you can run on your local. Like first is like pop install, like set up the environment for development by installing required packages, or pop new, generate a new parachange, palette or smart contract, pop view, pure parachange, or pop core smart contract. Yeah, there's a bunch of command here that I think like is very useful for like all the whenever you want to develop on Polkadot and using like Polkadot SDK. So here, for example, if I want, if I'm new to Polkadot SDK and I want to create a new blockchain, I'm gonna run like pop new, and then we can like create a new parachange or create a new palette or create a new contract. So I'm gonna run like pop new parachange. So when I run like pop new parachange, it asks me to select a template provider. So I'm gonna select like maybe pop, and then let's select the type of parachange. I guess like we can choose the asset parachange that configure with fungible and non-fungible asset functionality in the language of Ethereum. Fungible is basically ERC20 and non-fungible is simply like ERC721. So I'm gonna select the asset template, and maybe let's select the latest version of the Polkadot SDK. I specify the spec, I specify the path for it. So maybe the path gonna go to parachain testing. Maybe the parachain template. So the symbol and also like token decimal and the initial endowment. So waiting for a while, it's gonna install in the parachain template, and we can also like find the parachain template here. So you go to the parachain template, and then you also like find the node in the runtime, but there's no palette here because like this is a very minimal template that doesn't have like the palette the template for the palette. And here I already opened my editor, and you can also find the node and the runtime in the sidebar. So when you open the node and open the Mender.rs, this is some like key module in the node. And when you open the runtime, we also have the lib.rs here, which is like the main entry point of the runtime. We want to learn about these like defaults. First, about the runtime. So what the runtime provides to use. The first thing when you look at the runtime of the Polkadot SDK blockchain, you might want to find this part like the runtime mod runtime with the macro like frame support runtime. So this macro is basically provide the code and entry point that say like, okay, so this is my runtime, and I want to register some key palette for that runtime. And you can see here there's also like some comment that is a like create the runtime by composing the frame palette that were previously configured. The two steps to add a new palette would be register a new palette to this runtime module, and then like, you have to configure the palette, provide like some necessary variables and so like some parameters to that palette for it to work. And for example, like a very basic parachain system gonna have some these key palette. The first one gonna be the system and parachain system timestamp and parachain info. About monetary stuff, we're gonna help with balances and transaction payment. Balances basically provide the ability of managing the native token for your blockchain, and transaction payment basically like wrapping the transaction with some set of like fee requirement. So when you be like, for example, in the case of the Ethereum, when you post a new transaction, it asks for some like gas codes, and in this case like this transaction payment is gonna handle like collecting and also like validating those transaction payment. Then asset, because we choose the asset template for our price change, so we have like the NFT and NFT fractionalization and an asset. NFT, I think I don't have to explain about it. This palette provides you all the functionality to manage the non-fungible tokens on the blockchain, and the asset like provide you all the ability to manage the ERC20 tokens on the blockchain. And for that is like the core part of the runtime. There's also a few other things, but these things are just simply some like constant variables that we don't have to care about this yet. Depending on the configuration of the palette, you're gonna like need to provide like maybe like you want to define like some specific constant variable for it. There's another one would be the version. So the runtime version, this one is also important. When you want to do a runtime upgrade, you have to update the version of your runtime. So like all the node that using this runtime gonna like synchronize with the version of the runtime. Otherwise, like they're gonna be like deprecated in the functionality of the runtime. The another important point that I would say is the side extension. So a side extension basically wrapping your transaction with like some specific some special logic. For example, here check non-zero sender. So we don't want the sender of the transaction is like from the zero, like the zero address, the address that only have zero. We don't want that, so we have to add this to wrap our transaction. The another one would be like check specs version, like check the version, check the specification version of the transaction. I think it is related to the version that we just mentioned before. The another one would be check genesis, check error, check nonce. These also like some basic attribute of one transaction in the blockchain. We just mentioned about the transaction payment, right? So this palette like transaction payment is also provide is all the side extension called like charge transaction payment. And when you add this like charge transaction payment to your transaction, it's gonna like handling the validations and also like charging the user from like submitting just that transaction to the runtime. So that is the basic architecture of the runtime. And when you look at the config, you can also find the config of the asset. And here you also like learn like how you can like configure the palette. So like for the palette to work after the registration of the palette in the runtime module, you need to configure and provide like some key provide like the parameter to the palette. For example, like the data type of the item ID, and also the limit, some key limit for the attribute, the value limit of the attribute, the approval limit, the limit of like the total approval that one item can get. That's just basically like some basic functionality of the NFT on Substrate. Or you can also find palette asset here, like how you can like configure the ERC20 palette on like using the Substrate. That is like the architecture of the runtime. Now we go to the node. So what does the node provide? The node provide you a transpect, the CUI, the command RPC and services and service. This man is like the main entry point when like you compile the node to the binary. Let's run like the command and run like command run. And like the command here is basically like provide all the command for when you like compile your node to the binary, that you can run all these command to maybe like run the node, or also like clean the node or something. So I want to talk the first thing about the transpect, and the another thing about the RPC and also like the service. So the transpect is like the trans specifications of your node. Why you need a transpect? So the transpect is special because like it's define like some initial state for your blockchain on initialization. When the blockchain launch, it has the first block. The first block we're gonna call it a genesis block, and this genesis block gonna like initialize all the necessary state for your blockchain. So let's say like if I want my blockchain some set of accounts called maybe like Alice or Bob with like some set of the amount for these accounts. So I want to provide out those account in the change spec and also like specify the value for them. So when you look at the change spec file, you're gonna understand like what it means. When you look at the change spec, you're gonna find like, okay, so here like the development config for the development environment of my blockchain, and I want like the token symbol gonna be like gonna be called unit, token is decimal gonna be retail, and the format of the account address is like AS85 format is like 42, and here's then also like a code to like build from the binary. And here like initial, no, not initial later, but yeah, like here you like initial some set of initial account like Alice, Bob, Charlie, Dave, Eve, and these accounts are provided with some amount as well. So if you will look at yeah, here, so when you look at the testnet genesis, you can also like find the balances, and these balances is point to the balance palette that we just mentioned for about like native token management, and it's go to like all the acknowledgement account, and it's gonna like map this account with like some set of value at the initial state when like the blockchain launch. And we also like have a pseudo palette configuration here that you like provide a key and some set of like that which account that you want to be like the super user of the change. Here I want it to be the root. Yeah, and that's how the change spec work. The power of the change spec is like you can provide like some different change spec, like development change spec, testnet change spec, production change spec, and each change spec can be applied to like different environment depending on the use case when you develop the change. The things that is quite important as well in the node is the RPC. So the RPC, the node will become we like expose some set of endpoints that like all the user outside the node can call to the RPC to get like some data from the runtime or like to get some data from the node. Then that's how RPC work. And that is the basic architecture of the node. And we're gonna go back to our guidebook a bit. So like, and because we already go through some like real code, I just want to recap to you a bit in theory of all these all these like node architecture. So here's the anatomy of the substrate node. The substrate node contains three core technologies. The first one gonna be like the lib P2P for handling the P2P networking. Is like P2P networking libraries that like handling like all the peer-to-peer networking complexity that you don't have to care about it. WebAssembly, the node itself is also like have a WebAssembly executor. They're gonna execute the compile WebAssembly block of the runtime. Or we also like have the RenPar module that handling the block finalization. And here we have the architecture of the node that you can see. The runtime gonna sit on top of the node. Then you have like WebAssembly compiled to the WebAssembly. Then like the consensus layer are the underlying layer, and it's on top of the libp2p for handling the networking. And there also like provide like some description here that like remember to read it so that you can understand about like the node architecture correctly. And thank you. And that is the end of this section.